So the simulations are finished now, and we're going to see how they look like. We made 4 simulations. They actually took quite a while, but that's where we're going to make some adjustments. So if you look at the first simulation, which is going to be our wedge 0, so under we can just, you know, put a loading path here, and we're going to have some issues every now and then because of the not enough substeps. As we can see here, the polygon's exploding. And so what we can do now is to drop a blast swap right under, and this is going to allow us to get rid of the embedded geometry. So the proxy geometry, and here is our embedded geometry. So some things didn't work with one substep wasn't enough. This ship is passing through way too fast from it's traveling way too fast, so I guess it's the polygons are exploding for that reason. So let's go to wedge 1 to investigate, and we have a problematic cache here as well, but all this in just I think 1-2 frames. Maybe we got lucky with wedge 3, wedge 1, wedge 2, sorry. And okay, so that kind of seems to be working. We can put delete swap, attribute delete, sorry, the primitives have colors, so I'm going to get rid of that. Okay, so now I want to investigate how my simulation looks and how my edges look, etc. And I think this adds some nice shape to our simulation, as opposed to it's like a cloth simulation really, but it keeps compression working, so it kind of gets all this nice bendy metal as opposed to creating fractured areas. So we really get some kind of crumbling effect happening here, which is pretty cool. I think this version is okay, but then I did notice something, that the back of my ship gets really broken up badly. So I think we can use even more strength. So first of all, we can probably keep the wedge 2, which is 0, 1, 2, right, as our default substeps, which is now going to allow us to wedge other. So that's 0 is 1, 2, 3, yes. So then the next thing we can test is to bring this back to 64-bit, and I want to increase my fracture strength to, let's say, 30, even 40, to see what the result would be. And then I also want to be able to stop the fracturing, because the fracturing has a very heavy effect on the simulation speed. So I probably want to turn off the fracturing around frame. Let's load the cache again. I guess around frame 280. I guess we'll have some pieces already disconnected here every now and then. Yeah, because I don't want to destroy it and then keep turning into tiny pieces like this. So we can turn off the fracturing by just keying it, and that's going to actually speed up our simulation as well. So I would say 287. So let's put that back in manual. Let's go in frame 287. So we have the fracturing. I'm going to go back 1 frame, key it, go back another frame, and then turn off the keyframes. Yeah, it's automatic. So there's one good thing about so the key is working. There's one good thing about Houdini, is that if you do a mouse over on any attribute, especially in DOP context, most of the time all these attributes are probably point or can be driven by point attributes or primitive attributes. In this case, enable fracturing. So if I actually had let's say I'm having a lot of trouble, like in order to optimize the simulation, I would probably go back here and then choose the back side of my bus. In this case, I think it's this part. Let's double check that. This is moving forward, right? Yes. So I would probably first I need to check if the enable fracturing is supposed to be on points, or let's bring in the help here. I guess we can do that from here. That's gonna be better. Enable fracturing. Load the help file. And parameters, I suppose. Attributes. And I'm going to go down a little bit more. It should be not really. Where are the attributes? Will be on the solid object, I think. Model. Uniform division fracturing allows fracturing for this object. Yeah, but it's a point attribute that is supposed to be on, I think it's gonna be on the object, not the solver. Is that where we clicked on the first place? I'm gonna scroll down. I'm pretty sure one place it explains. Fracturing solid this type. Fracture finite elements, collision setting up. Fractured solid object. Enable fracturing. Allows object fracture. Realistic objects do not have the same fracture threshold everywhere. To vary fracture threshold locally, you can fracture on point attribute. So I would assume the same thing with the enable fracturing is going to work as well. I guess then we could just fracture part is the attribute as well. In that case, if I had to optimize this better and then make it work faster, I'll probably create a sphere, let's say. Around where I should. I can't see it. I'm gonna move it to where I should. Okay, so something like this, and then I'm going to, oh no, this is not what I asked for. I'll just create it inside. Let's go to our solid sim object. Let's just create it here. It's all the way there. I want this to be something big. Let's bring it back in. Okay, almost there. If you look from, I think this was moving left. Okay, so that's the back end I need. There, there. Move it down, kinda in this area. Let's make it even bigger. Okay, so something like this maybe. And because this is the part that our ship enters the bus, so we can say whatever is inside here, point attribute enable fracturing 0, everything else enable fracturing 1, and then even the actually I think it's best to show. I'm going to make this. We can fill it up with points from attribute, points from volume. Points from volume. Actually, that's not the most efficient way. I'll show you the efficient way. Scattering points inside here to do attribute transfer is not the speediest way to do it, and rather we should probably make VDB from polygons, and we convert this to some big volume. We can even do density. Okay, and then we can drop in an attribute wrangle here. Second input. So we're going to use volume sample to create. So by default, I want to create fracturable. So it's f at fracture, enable fracturing, enable fracturing, I think. Let me double check from inside the .NET. Let's go in here, the enable fracturing, yes. Enable fracturing equals 0. Okay, so that's an override. So we need to obviously test this because I'm not sure if it's supposed to be an f, which is a float, or integer, but we can test it before anything. So we can go into our first frame, 282, and I think we don't need to change the key anymore. We can drive this from here because per point based. Okay, let's try to cook the first frame. Okay, I'm going to, for testing, I will have to turn off the embedded geo, and I'm gonna put a little note here so I know that I'm a bit paranoid about this. I don't think just turning this off works, but it probably does. Okay, so in this scenario, I think it should break in a certain area and not break in a certain area. We need to probably turn this off because it's driven by point attribute. So if we go and expand the bus now and the geo, sorry, if you click on it, you should have it on the points that explains somewhere. Enable fracturing is now as an attribute. We don't need these colors as well. I think it's just too much information is coming from solid fracture, so we can turn that off. It's just creating a lot of attributes. I think that's where it's coming from. Enable fracturing, group P, interior, exterior, all that jazz. That's fine. So if I go inside again, if I press play, I'm gonna switch this back to 1 for speed reasons. And I can even turn this off from here pretty much, or I can key it in per object. But this is per solid object, this is per the entire solver. So since there's 1, that should be fine. I'm gonna turn this off because I want to see if the point is going to take care of the point attribute. So right now it shouldn't break at all based on what the coming information, which is, I'm going to reset it because we changed some input. Okay, which is coming from enable fracturing. So let's maybe hide everything just to make sure that this is working. Enable fracturing, and this principle applies to pretty much all solvers in Houdini, right? You can use this overrides in points, etc., everything. So now it shouldn't break at all, and it looks like it won't. And then it's gonna create some crazy stretching because it needs to break in order for the ship to go, but it cannot. So Houdini will try to solve the problem, and it will just end up being stretching because none of these objects are breakable at the moment. Okay, so that's kind of working. So now let's try doing a partial fracturing on and off to see if this part is gonna stay intact and this part is gonna break. So let's stop the sim, go to our first frame, 282. Okay, we're gonna go like this. So I'm going to copy this guy. I'm gonna say maybe you want to draw it, or you can do a paint over, etc. Default fracture. Okay, and then here is what we need to do is everything else that stays inside this volume area to convert to 1. So sorry, anything that is not inside to convert to 1, or we can actually do it something like this then. If you're inside, you're breakable. So something like this. It's still gonna, the other part is still gonna bend, it's just it's not gonna break. Okay, in this case we need to make sure that, although there's one problem here, is that you need to make sure that you have enough geometry inside so it can do the split from the border. So in this case here, which should be okay, we're gonna try. The way volume sample works, I'm going to say float, and actually let's observe the values. F at inside equals volume sample there's a little typo, volume sample open parentheses, so I want my first input to use so this is like look to the first input, which is the second connection, so there's 0, 0 is 1, and then I want to use, I think it's just like this. I'm not sure, I have to check. And I should return a value to say if it's inside or not. No, I think we did a little typo. Geometry, prim number, position. Okay, so that's because I might have different right now I have density, but maybe I have density 2, and that 0 says use the first one, 1 says use the second one. But as the manual says, maybe it's safer to do actually to write the volume name, so we can just do this density, which should do the same thing. Okay, so in here now I have some inside values that are 1 or 0, so I can investigate that by putting a color or just a visualizer. So visualize, let's plug this in here, and I want to visualize my attribute inside. So this part is gonna break, this part is not gonna break. Okay, that's exactly what we need, but we didn't write our statement there. We just said check what's inside. So I don't want to export that out, so I'm gonna say float, and then I'm gonna say if inside is bigger than 0, f at fracture, I need to just copy paste the attribute, enable fracturing equals 1. Enable fracturing equals 1. Okay, and that should now create half of the object fracturable, the other half unfracturable. Let's check again. Visualize, visualizer, enable fracturing. Okay, so now this part should break, this part should not break. And if we go back into our simulation, our first frame, and I'm gonna press play, and let's see what happens. And if it takes a bit longer, it's good. If it does, we may have to turn on the settings as well from here as an overall override. So that's the part that I'm not sure if you need to have this on, because I don't know if this is actual overall override. Sometimes from version to version things change, so that's what we're going to check as well. As soon as, okay, so it's not breaking, I would say then we probably should turn that on. This is on here, this is on here. Let's press play again. I think it broke altogether where it shouldn't have. Okay, we're gonna need to check the documentation for proper attribute designation. Because I can see the cracks here, so it's probably not working at the moment. Okay, yes, I think everything is broken. Since it's not really moving fast. Okay, I'm gonna pause the video. I'm gonna wait until it advances the second frame, and then we'll find the proper attribute location so we can apply our optimized settings. Okay, so I found the correct attributes, and which was, I had to search through the I had to actually search the enable fracturing. So this is the part that I want to actually explain something. As you can see that in every version, certain things change around, certain attributes move around, and it's impossible to know what is right, what is wrong. Every version, because we can only remember so much. There's so many solvers, etc. But it is very important to understand what can be done in Houdini is super flexible, and occasionally we get questions asked around like, can we do this with Houdini? It's like, yes, it's a computer. You can probably do anything with Houdini. I mean, if it's about VFX, and you can probably write an accounting program using Houdini. Not that it will be the most efficient way to do it, but you can. So it is important now is that we should know how to search for the information we need. So as you guys remember, I had to pause the video to figure out where is that attribute, where is it supposed to live, and etc. So I kind of finally found it. So the attribute I was interested in for is enable fracturing. So I find that under this guy, after I searched it, it kind of gave me all the information I need for the solver to work properly, so I can customize it as much as I like. And that includes the fracture threshold. So each one of these attributes here pretty much can be turned on and off, point based or vertex based, optimized to simulate our to basically create it as fast as possible, as custom as possible. My help is not loading now. I want to show it to you, but I'm just gonna write it again. Enable fracturing. Come on. Enable fracturing. Enable fracturing. Enable frac. Let's go back to upper level. Enable fracture. Why are you not working now? Okay. Select the finite element solver. Load faster, please. Yes. Okay. So in here, and I start dragging down, and it's very well explained what the dynamics node does. So if you can go like stiffness, and then it tells you the point and tells you the attribute type you need to put inside. Some of them sometimes are vertex attributes, etc. So we can change the solid stiffness, we can change which part is inside, which part is outside, even material types, the UV directions, etc. There's a lot of possibilities here. Fracture part, integer. Enable fracturing. So this is what we were looking for. It's either a point or a vertex, but it needs to be an integer. So our problem was we were giving it a float. So now I identified the problem that I was having, and I changed it to a proper attribute type, and now it's kind of working. And then we can also adjust the fracture threshold as well as all these other attributes. enable fracturing whatsoever. Okay, so fracturing control attributes, material property. So when you create a simulation with fracturing, it's recommended to specify chunks of tetrahedrons that you want to stick together. Otherwise, the fracturing process may create a very large amount of separate pieces, many of which may consist of single tetrahedrons. For this purpose, you can assign non-negative integer to each chunk using the fracture part attribute, which is also creating this colorful look here. So basically now the manual is saying let it cook. It means that this guy, solid fracture, selects a group of why is it taking so long? Voronoi fracture, it's doing something that was not taking so long. So it basically it's creates those randomly grouped colors, and then it gives them a unique ID number. Then it basically says don't break the simulation into smaller pieces than this, which means we could probably just select this part, and instead of create a fracture threshold 1, we could have just given it one value, so this would be like one piece that won't fracture as well. So there's a lot of little ways to do this. One of the cool things that you can do also, and this is one thing that I did in Ghost in the Shell, when Major is pulling the spider tank's hatch up, I used solid fracture to do the robotic gel tearing, but I also implemented into that simulation a growth simulation inside the solver. So as soon as we detected a rip, the fracture enable fracturing start turning from 0 to 1 based on a spreading algorithm, like the diffusion reaction, which kind of gave a bit more interesting look, because it was dynamically, instead of hand animated, it was dynamically spreading and turning into 0 to 1. This is now taking forever. I'm gonna kill it, and so we can move forward, because I want to review how our simulation looks and probably run a longer sim. Okay, am I on manual? Yes. So after all the information, and now we have, once we run this simulation again with the better settings, so we can now, because our simulation will go faster, we can tell certain of these parts to rip apart or not to rip apart, or we can even just go like half, you know, like maybe just rip from that part, etc., which is going to look a bit more interesting. We had our glass separated from this as well. So if I go ID glass, I'm going to get my glass separate, which I can use as a source for my bullet sim to actually do a proper glass shattering on these guys, or just let's every tetrahedron to spread apart, so yeah, we get more smaller pieces. Okay, so we were checking number 3, right? Number 2, sorry, yes, number 2 is the one that doesn't break. Okay, I'm gonna bring in, so we can turn off this guy, because this is what happens to our ship. Ship B, let's roll back. Okay, if you look from the flight cam, I think for this one you almost want a different camera angle, because we can't really see the cool stuff. I guess we can create a new camera just for this, maybe camera, so let's name the camera 2. Where is my camera 2? Flight cam, this can go here, this can stay here. This is wing cam, so we can create maybe another camera on the other ship. So I guess if I just plug this in here, it should go to wing cam 1, should go to the proper place. Yeah, and then we will actually fly through our bus destruction. But let's give it a bit more nicer angle here. So I guess a little bit to the center, and then higher. Oops, too high. Like this, further back. It's almost like a crash through camera. Okay, since we didn't simulate long enough, we'll have to cut our camera at frame 300, but that's I think pretty cool. Okay, now I think we can move forward to create our secondaries for this simulation, which is our particles and the PYRO, obviously. And we get all the buckling and everything. Solid Solver has some nicer features, like creating broken up edges, and then it kind of gives us some detailed information that we can use from, though not on the embedded, but the opposite of it, from the simulation geometry. Our resolution is quite low now, but if I put, like, we get attributes like I think we turned those on, right? They should be on the point attribute. So if I put color swap here, ramp from attribute, I think I'm gonna get rid of the CD attributes so I can see them a bit easier. Attribute delete all the CD. No, it's also CD. Should give me less attributes to deal with. So all these forces, etc., kinetic density, they should give us some nice information for we can use. I'm going to show you contact force. This contact force. There is dissipation density. So let's have a look. Let's put a color here. Color swap again. No, this is not. We already have one. So for example, dissipation density. Dissipation density. Obviously, I think this is gonna be a quite high number, I would believe. So we have internal force. Now that's the vector. Inertial force, that's also a vector. External force, vector, dissipation density, and then kinetic density, potential density. So that's goes to some really big numbers, and they are on points, so this should give me something to visualize. Let's go a little bit further. Kinetic density, maybe dissipation density. Well, I actually, because I use those for creating the sources, so let's just move forward. So I want to cache this out as it is without these points, but that's fine. This is not an expensive operation, so we can just say bus to render. Okay, and now we can go under solid sim and create another geometry node, maybe here, sim solid PYRO, solid secondaries maybe. And I think now here we can continue. Actually let's just stay in here. I think it's gonna be easier for us to just go down. I'm just gonna change this color to black, so I know that this is a render point, or it is an extraction point. We can organize our scene a little bit better. As usual, this is my collider. This is my sim. Let's put on manual before selecting a .NET. This is my simulation, but solid simulation, because we're gonna have secondaries. solid simulation. Okay, let's move this here. Further down. Now this part gets a bit busy, so I need to figure out what I was doing. Bus embedded. Okay, so I'm gonna get rid of. So I'm gonna create my source points, but not from glass. I wanna emit some particles. Use these particles to emit fire. So I'm going to put a blast here. We can load our sim. I want to get rid of the glass. Okay, let's go a few frames, maybe just when it kind of just breaks on the edge. Okay. So what I want now is a technique that I use for when I was using the debris shelf tool. So I'm going to run using the fracture part information. I'm going to create like almost like a packed object from this mesh, which I'll show you now what I mean. So I'm going to create an attribute wrangle because I want to emit points on these edges, and then I want to be able to use them as a particle source for anything. But for that to work, I'm going to use a customized version of debris source shelf tool, but we need to satisfy its requirements for this custom version. So try to follow with me. I'm going to create a new attribute called name2, integer to array. I add fracture part. Okay, so I'm going to use this. I just kind of pretty much converted the fracture part to are we deleting fracture part attribute? We shouldn't be deleting it. Why is it not visible? Oh, it's because this is my embedded G. That's correct, but where is it? Primitive parent. Why is it 0? I need to see. It shouldn't have been 0. Am I deleting it somewhere? No. Primitive parent. Oh, this is changed between these versions again. I was supposed to see. Okay, I'll try to load my other. I'll check it from my other scene. Loading my scene. I'll find it now. Okay, here, frame 900. So if I just trying to load it in my other screen to compare the attributes. Okay, let me load this in here. So this is the scene from my other file, pretty much the same, and I bring in the embedded geo here. But then I have my fracture part attribute here, which I don't see anymore. And I'm curious why not. Oh, because I transfer it. Yes, because it doesn't come on the embedded side. So that's what we need to do, which makes sense. Okay, that's all good. We have that here already. So I am going to create and paste this. So this is the keep embed. And this is the tet geo. Okay, so if I do that, that's what I get as a tet geo. That's fine. And I want to dop object. I think I can use the dop object to get rid of our ship as well. Let's see the attributes. Dop object. Where is my dop object? Hide dop object. It's coming empty. Okay, that should be fine. I guess now I can drop in an attribute transfer here and just transfer my fracture part from my primitives. Okay, and if I go here now, I should have my fracture part, and therefore here I should have my groups. Okay. Now I want to create a timesheet. Basically, I want to go to the last frame pretty much of my simulation, because that's where I have the most of the pieces already separate, right? And that is when is 300. We simulated up to 300. Okay, so that's where I have all my pieces separated. I'm going to put a time blend under here. It's the usual settings. And now I'm going to put a for each loop for each named primitive in here at this frame, which is going to give me each one of these pieces. If I go like this, because here I named them, right? I named them to name2. So in here I can say name2. So that should kind of give me each piece, if I go like this, separated, so I can work on them. So now what I want to do is I want to figure out the edges of this geometry. So I'm gonna limit my loop to one object, so I can see the result without changing the thing. So let's create a group create. I'm going to change it to edges. Let's name it to edges. Okay. Turn off base group. Turn on include by edges, and I think that should be it. We enable, no, sorry, we need to turn on the unshared edges. So that kind of gives me like an edge group, right? It kind of picks the cut edges. So then what I want to do is change my edge group from primitive, from edges to primitives, because it's an edge. So then it's going to be group promote. Group promote. Okay, so I'm going to select my edge. The new name is again edges, but this time convert from edges to primitives, because I want to keep the neighboring primitives, right, like this. Okay, and now I want to attribute promote my name attribute from here to, that could be the same, doesn't matter really, from primitive to point. So that's name2, primitive to point, because I had it in the first place here as you know what, I'm just gonna do a little bit more cleanup here, because it's quite a lot of attributes actually I don't need. Let's do it here. All the CD here, if there's any CD here, same thing here, all that stuff. And okay, that's better. So now I want to scatter points on this group only, so I can drop in a scatter swap. So right now it's scattering everywhere, right? And I can type something like, I think what, let me see what I typed. I typed 10,000. Okay, but not everywhere, but only on the edge primitive. So I have my points scattered. That's basically where I want to start creating some fire. Then drop in an attribute transfer, transfer the name, which was, I thought I deleted the let's reset. Okay, then I want to create the name2, transfer the name2 from primitives, from the here that was on the primitives, which we promoted to points. So if I go here now, each of my points will know where they're coming from. In this case, this is the one piece. I'm just going to rename it from name2 to name attribute rename. I guess we could have worked a bit clear at the beginning if we one less node, but this is really fast node, so they don't really matter. So then I want to create a chunk ID, a clean chunk ID using the loop that is looping. And I want this to be a point integer attribute. So in order to get the iteration of a loop, we click on this button, create meta import node, and in here, in the detail, it's going to tell us, okay, this is iteration number 3. So I want to create an attribute create. Sometimes I use attribute create, sometimes I use attribute wrangle. It's really the same thing. I'm just using mix of everything here just to give the idea for now. So that's going to create an attribute as the name stands. And we want a point attribute that is an integer because the iteration is an integer. And I want to write values to this value as a point. So I should have this. It's 0 now, but what it should return in the end is 3. So how do we do that? That's the expression detail, because that's a detail type of attribute. So we need to fetch from the detail tab of the geometry spreadsheet. That kind of can give you the idea. And I'm gonna name it. Let's name this to something more similar. Iteration, detail. Okay, so in here we can say the same thing. As soon as I type I, it should show me. Okay, and then close the iteration. That's how you fetch the name, because it's written in the documentation as well. And because this could be a vector, so we want 0. And there's a little typo there. The tail. Okay, so now it's 3. So if I can now plug this back in here and just let it run for the whole separate pieces, we're gonna have like a point scattered at the edge of every fractured piece. So now I want to point deform this with this guy here, point deform, instead of doing this every frame, which might also work, but it won't work for what I'm trying to do next. So okay, this second input is the frozen input, third input is the deformation. So now if I scrub it, my points hopefully will properly, oh, I think we didn't change it shouldn't calculate every, oh yes, because we need to break the expression here and go to the last frame like I said, which was 290. The last frame of our sim, what was it? 310. No, 390. Oh, we didn't go all the way. Okay, so let's put it there, 300. Because now we should be able to move it a lot faster. Okay, so what we can do here is actually we can cache that out as well, so it's just a bit faster. Actually, that's what I want to do here. Do my cleanup and then do a file cache. I guess we can just copy this, paste it here, give it a better name. Okay, so I guess we can do this FEM, BusCrash, maybe bus embedded, BusCrash embedded geo, pretty much, and that is the wage 2. So we keep it same. Sim embed. Okay, and just cache it out to disk. So it reads fast, so we can scrub it a bit better. Eight more frames to go. Okay, so if I think I can now scrub it much faster. Okay, which means just let it cook once. And here I should be able to scrub it much faster. There's one broken frame there. I wonder if it will be faster to... I'm gonna try attribute interpolate. But it's changing it. No, it doesn't. Let me... Here are my groups. I don't think that's gonna work. Okay, so that's fine. Although I think it kind of breaks these frames, and it's because it doesn't have any... I think the radius is too high. Maybe let's try to make that a bit smaller. Yeah, a bit smaller even. Okay. And if you move frames, okay, so that's kind of working. That's good. Now what I want is to basically emit points when neighboring points are separating from each other, right? So the debris shelf tool, debris source, does that, but it's designed to work with the rigid body simulations, not with what we have here. So what I want to do is to go into debris source, change my res frame to 282 because that's my res frame. So I already have points in my scene, but debris kind of does create points from the rigid body simulation, so it kind of does something similar. It converts the edges to curves and then scatters, but we already have that. So what I need to do is pretty much skip this part. So all my points will go straight into the first input, and also here. So because I have a point count that is static enough, so that should do the trick. We can have a look like what is this doing. This tool creates IDs based on point numbers, and since our point number doesn't change because the way we scattered and did the tool, so I guess I can go back to my first frame, 282, and then it kind of finds the closest points to the neighboring name, and it freezes that at that frame, and then it kind of puts it in a solver to solve and checks the point if it's in the radius or not. And you can all I'm not going to go through this node by node because it's not a wax lesson, but if you are curious to see how it works, it's fine. The other thing that we need to make sure that we have proper numbers is to have enough points for our simulation source. I'm gonna go, these numbers were tried based on my other simulation. So if I now press play, hopefully as soon as my pieces will start separating, I should start getting points. Okay, so that's a bit maybe too much lifespan. So because in this frame, I think these are already kind of breaking here. So let's have a look there. It's a bit too much maybe. So when this is less broken, I guess we're gonna have less pieces. Let me try to play with some values. So that's not what we want. This is not the part we're looking for. Here, maybe something closer. Okay, so search radius, something longer. Okay, so it starts pretty much getting more and more from, so already more on the part that is broken and less on the other side. I guess we can ask for even more search points. Let's go maybe 10. I don't know exactly what is the criteria here. I guess the radius. I suppose 500 points slowed things down quite a lot. So let's stick to 100. Let's increase the radius. Okay, so that's probably fine for now. If I overlay the geometry here, and this is the parts that I'm going to get the points more and more visible. And when I have something that breaks a lot less, it's going to be concentrated exactly on this area. We may not see, but it's actually broken on these edges. Okay, so now my particles are ready. I really do want to cache these out as well. So I'm going to copy paste this guy here. And let's call this BusSim embed, BusSim PYRO source. And I guess we can copy paste this. I'm gonna cache that out as well. So now we need to create our source for our simulation. So I guess we can turn this just into fuel, pretty much. Because they're consistent topology, we can have those to have velocities, or we can just copy the velocities. Actually, I mean, we could have done that, honestly. And they get older, they have age because of the debris source as well. If I put a trails up, because I'm gonna need that, compute as velocity, that should still work. Based on ID, do they have IDs? They don't have IDs. Okay, so that's not gonna work. Then we can do this here. And then transfer those to the points there, right? Attribute, I guess we can do that. That should keep the velocities. Let me see. That's frame 282. Let's go to 282. Reset. And oh, it is failing to load here because this is set to node. Okay. If the trail swap fails, it's sometimes because of this. It's looking for a frame to check and can't find anything against. We should have velocities that are not 0. Yes. Okay. So let's just recache that. Okay, back to our source, create a PYRO source. I want source fuel, you just change it to like this, so you get, I think, do we need density? No, we don't need density, it's just temperature and fuel we need. So then under that I need we're gonna play with the settings, but this is the default way to do it, right? Attribute noise to create some noise, and then I think we have a lot of attributes which we don't really need to cache, so you can get an attribute delete, and I'm gonna copy paste the attributes I need from my other scene, just the text, so I don't type everything else here, which is just this pretty much, and I don't need anything else. Or groups, so we can do group delete. So this is the most basic form of caching it out, I suppose, which we can cache this, because I'm going to use a different method this time to source them. in my scene. So normally we get the volume rasterized and then we use that one. I think we did that in the other .NET, right? But now I'm just gonna use the gas particle to field, which is still a valid workflow, which is still a quite good way to source volumes into the sim. So here, for example, it's using the volume source, which works fine. But I always thought that this kind of gives a bit more, a lot more actually, control in my .NETs. So I'm going to pretty much cache this out. But let's just get the attribute noise and PYRO source, I think, working properly. So what we have is all of this we can leave as default. I think this is probably, where am I? Particle separation. This needs to be auto. So here it should give us, I think maybe if I put it here, it will be easier to see what I'm doing. Base P, I don't need the fuel, P scale, temperature, velocity. Okay, I don't have anything else. But I do want randomization. So here I'm going to put this here as a default. So I want to randomize, not the color. I want to randomize fuel. So that's my visualization for my randomized fuel. This can be animated, that's fine. I think we can have 1D, there's no need to create 3D noise. So that's my fuel values getting randomized. I can remap the noise from -1 to, I don't know, 5, just to give a bit more value. -1 will be negative, and then I guess I can just do the distribution like this. So it kind of like does a fall off. This is the speed that it changes per frame, which is fine. Element size is the size of the noise. So we do want something granular. Just trying to create some randomness pretty much. Okay, so here I'm clamping it to 0, and here I'm clamping. I can do the clamping here. So this is fine, and I also want the same thing for temperature. Okay, and I can do that as well. I guess we need to use one only. Yeah, so that's my temperature, fine, fuel, fine. Okay, so I randomize my values. I think this is quite fast to scrub. So there's no problem there. Okay, so the other thing is that I do remember keeping the chunk ID here because we did give a chunk ID here, right? So what I can do is because I don't want to create one big simulation, let's say I can simulate this in 10 chunks, right? Or I can just use a chunk ID, but I might end up having too many chunk IDs. Where is the chunk ID? Was it here? Fracture part. Because I also have the fracture part, I can use the fracture part as a simulation method as well to distribute how many simulations I want to make. I wonder if I can just go to my first frame and get some reasonable distribution, 282, reasonable partition size for simulation. So here I have my chunk ID. I think I can attribute copy this based on, okay. What if I create, what if I want to 10 simulations instead of 1 to add some more detail to it? I guess then I can create cluster points. Let me see if this actually goes through. Cluster, oop. Let's dive back inside. Oh, what did I do? I changed the layout. I should have saved it. Okay, I should save it probably. Let's save this as BusCrash 2. Okay, 282. This time I'll try to be a bit more accurate with my buttons. Cluster points. So if I do that, it's gonna give me, should color it as well to show me visually. Yes, okay, so basically I can now tell this guy to be one sim, this guy to be one sim, one sim, one sim, one sim. But what if the pieces are going really far away from each other? That's kinda, because if these pieces don't stick together, and then a piece from here goes there, a piece from here goes there, then it's no different than making one big sim. So maybe we're gonna skip that for now, because if we need to split our sims based on our attributes, we already have actually here, somewhere here, we have the fracture count, we have the name. So we can already use the name. Yeah, to split our simulation. So maybe it's important that maybe we keep our name attribute. Okay, in case we want to split it. Because if we do a color swap based on name, random points, random from attribute name, I guess I need to turn off my visualizer. No, where is it? Because these are my names, so each unique color can get their own simulation, hopefully, but that might mean that they stick. Yeah, so basically all this yellow guy can have one high-res sim. All of these, because they stick together, so I can have quite a lot of wedges here to have the ultimate detail. But for now, we're not going to use it. We're going to only use it if we need it. Okay, I'm going to put another null. We are ready to put this inside the simulation. Out fire source. Drop in a .NET. Fire sim. Or explosion sim. Let's call it explosion sim. Explosion sim.net. Okay, let's go inside. I'm gonna put this starts in which frame? 283, so we can change it to 283. 283. Put on manual, dive inside. PYRO solver. Smoke object, as usual. Now the way we gather this information is going to be a bit different than what we're doing. So first of all, we're going to need our collision shape, obviously, which we will bring in here. Merge, but I'm not going to activate it now. I want to make sure that my sources and everything work properly. Static solver. This is not the correct input. Left to right. Okay, that's fine, but I'm going to disable this for now. Okay, now I want to bring in my source points, because I'm not going to use volume source here, so I'm going to use gas particle to field. But for that to work, I need to somehow bring in that information, okay? Which means I need to put in an applied data, so I can bring in additional thing and then merge it to this string. And then I'm going to bring in soft geometry, which is coming from outside, and that's going to be my source points. Source PTC, right? Source PTC. And I can hook this up here. And then I want to basically say I would like source points to use this information, and I want this to update every frame. So I need to change the default operation set always, so every frame it updates with whatever the state of this node is. So that's important. And since we have, I think we can even, I'm not sure, but that's fine. And then we can rename this to something else. So I want this to be source, SRC. Okay. Bring it in here. So now I will, if I hide everything else here, I will see that it's just basically copying the information into this context, but at the moment we're not doing anything. So what I want is my starting bounding box to be as big as my source at the input, but for this I can just copy this guy and then define my bounding box sizes, and let's make that bigger for now. So it's b box out source, so that's size x, so d at x size should give me the proper size on the x-axis here, but that's only gonna work when we initialize the sim. So that's y, that's z, but this is still at the world center, so just paste the same thing, change the b box to centroid. For those who already has purchased my previous tutorials, you'll see that I use this quite a lot. It is still valid. It still allows me to avoid a lot of issues that I might end up having. There's one problem here on which b box. It's the size, the z. Yeah, there's a point somewhere that we're not interested. Let's just get rid of that. I'm just gonna put a delete here to make sure that I don't have anything else. Be careful with all this stuff. It might cause a lot of issues. Yeah, I just need this size at the initialization, so I just want to get rid of that area. Delete my, I guess, bounding volume. Yeah, that should work. Bounding box, maybe 10, 10, 10, and it's gone because that's the default area. Yes, that should do the trick. So maybe even smaller. I don't remove something I don't need. So if I go inside, okay. So I have the proper size now. So that's the first frame I need, right? And I have my sources, I have my bounding box applied properly. Now I need to feed some proper information into my solver so I can actually emit gas and then make them explode whatsoever. So we're gonna need a gas resize fluid dynamic for resizing our container properly. And this is, again, the padding and everything is gonna be defined by how fast your simulation is moving whatsoever. I know that in every frame I want proper expansion of my resize bounding box, so I'm going to turn on tracking object to my source. So it's going to update properly. And max bounds I want to turn off. No, sorry, keep it on. Well, we can turn it off. If you want to put a big box, let's say you're going to simulate and you'll only see a certain area, you can just put a big box that and then use it to clamp based on object or something, but right now I don't need that. So that's my resize. And now how do I feed this information back into the PYRO solver? By using gas particle to field, gas particle to field. And I'm going to source this presim, which is where the resize is plugged in also. So here, presolve, sorry. So this is my temperature. I'm just going to copy paste this to field. And I'm going to copy paste this to velocity. Plug all this here. So if you select the first guy, this has a lot of information here, but we don't have to vary so much. So first of all, our particles are not coming from the geometry here, but they're coming from the source because we changed the data name to source. So that's the data name. So let's change it to src for all three actually. And in the first one, we want to use the temperature attribute because we did create it outside, and I want to pass that information to the temperature field, which comes by default with the PYRO solver. And this we're gonna play with. I want to add every frame, not copy the density. And for now, I think the rest we can keep as it is. So then I want my fuel, which I already created as well. Fuel, not the particle group here. Instead of add, we can also limit, if we add groups, we can also limit them like window, I don't know, plastic, whatever, this and that, maybe for coloring purposes. Again, the fill is in add mode as well. Extrapolate it. I'm gonna use for 1 now. Depends on the detail what we have in our source. And same, but this time V to val, because the particle is V. And this usually has a lot of strong effect on it. So I'm gonna dial that the destination to 0.3, source to 0.3. And I think that's it. So now if I actually press play, maybe I will see something happening. Yes, I am. Okay, so it's kind of working. That's good. Obviously our bounding box is not expanding fast enough, but our resolution is too high anyway, too low. So we can put some more padding to our resize, maybe 4. Remember, our object is growing really fast. Okay, so we are hit here. So the other thing that is that I don't see much advection, so that's what I want to sort as well. I can use these objects as an advection, so it's gonna kind of do a little bit better push. So I'm gonna create another subgeo. I'm gonna create a field force. I wonder if I can just plug this into advection here, see what it does, to be fair. No, not really. It should have worked, but maybe I want to have a bit more control, so I'm gonna use the field force here. So I do want to bring these points again, actually, here. And well, actually not, because I have gaps in this one. I actually want to bring my proper geometry here, which is this guy. No, which is this guy here. So I can drag and drop this here. I do have velocity, I believe. Yes, so that's fine. So let's go back inside the .NET. This needs to be always, so it updates every frame. So what I want from this geometry is velocity, and then as soon as you put the proper value, proper attribute name, it should show you which direction this needs to go. But you need to obviously change the vectors maybe to something small. So that's kind of push my simulation along those directions, and it has this cool feature like max distance. I find it quite useful, so I'm going to change it to 5. Okay, so let's turn off the, we can turn off the guide geo. So now let's try to press play, see what it does. Okay, maybe we need bigger number. Maybe I'm gonna go 10, another 10 here. Let's press play. I think it's kind of working, maybe not exactly. I don't really think it is. Okay, maybe force attribute. It is the V, right? Yeah. Okay, I'm gonna put 1000 to see if it's actually doing something or not at all. Yes, it's actually working. It's just the value is different. So let's go like this. Yeah, it's kind of working, but we just had the wrong value. So let's go maybe 100. Okay. Now, we are emitting way too much than we would like. Let's drop the resolution to 0.5. It's gonna kind of create a lot less but more defined source. And now I want to create some explosiveness to these, so we can have something exploding. So let's go to first frame again. Time scale is fine. Temperature diffusion, I don't want it to diffuse so much, but I want it to cool fast. Buoyancy, I don't want it to climb up so much. Combustion, I want to have combustion, which is on by default. So smoke, I want to create dense smoke. a lot of smoke. Flames, I think we can have even longer flames. Okay, smoke is fine. Heat cutoff. Want it to not so make so if you do, let's see if it does. The value of heat field at which smoke is emitted. This option is only available when source is heat, for example, if heat cutoff is 0.2, vice versa. So that's fine. I think I turned on flame contribution to 625. I'm just playing with these values until it kind of gives me something more interesting. Flame influence cooling rate. I turned it on, I kept it on default. And advac fuel, I think this was too much, but that was based on my simulation again. So if you need to change it, change it. Fuel inefficiency, I want some unburned stuff. I want a bit hotter areas, and gas release for now is fine. I put it to 6, maybe I had a big dissipation, big explosion. So I want it to dissipate. I want a disturbance 2, so if I open the disturbance tab, I put here, based on velocity, cutoff is 125, block size is 4, using control field temperature, and I change my control influence 3 to 10. Shredding is on. Is it on? Yes. Put 30. Wow, I don't know why I put so high. Well, maybe that was finally the result I was getting properly. So in the shredding, I did change my clip gradient to 1.04377 and stretch to 0.25. Okay, I'm not actually remembering why I did that, but I'm sure there was a reason behind it. Advanced top, I did change. I excluded the gravity, from my force. And then I guess we need to color it properly. Let's claim it explosion, so we can see what we're simulating better. So maybe let's cook it for a few frames. Oh, I broke something. Oh no, it's fine. It's just turned on the multi-visualization, but I didn't put in my density here. Yeah, so that's... Oh, I think we have a lot of advection. Obviously, we need to get rid of that. Let's put the density again here. And let's change the emission. Under the emission method, we can change our visualizer to be heat and temperature. But from what I see, at the moment we have a lot of advection, so we definitely don't want that. So let's go, I don't know, 25, and I'm gonna decrease the distance, let it roll a few frames. Okay, we're getting some nice breakout. I think we're still getting a lot of I think it's gonna over explode. We may have too much temperature or fuel. We may have to dial these down. Those are the settings that we need to be they are mostly simulation dependent. There are ways to fix them, but first I want to fix if this is coming from the field force advection or if it's coming from the velocity. So what I want to do then is to pretty much multiply my velocity to 0. And go to 291 to see if that's from my velocity or my field force. One of them is pushing the smoke too much further. I'm sure you're gonna see now. Okay, it's a lot less now, definitely, but we do still want a little bit of inherited velocity. You don't want it like completely gone. We can do this here too. I guess we can key the field force. In that case, we can start with 0.25. Key. I broke my shortcut. but then this needs to be set to always, so it updates every frame. I'm gonna put on manual, and then maybe here it's 0, and keyframe. Okay, so automatically keyed. So if I turn this back onto auto and step through a few frames, yeah, but now it's not moving at all. Not enough, and we're creating too much density. Okay, I'm gonna keep this at 25 and increase this to, what was my original value, was 0.3, so I'm gonna make it maybe 15, keep it half. Okay, let's step through a few frames. Let's play with the colors so we get something a bit more interesting to look at. Okay, like I said, we are creating too much density, I believe, but let's get our colors correct. So let's create some heat. Okay, kind of looks like an explosion now, a bit more. We still have just way too many bubbly mushroom looking areas. I think I can compress it a bit more. Okay, and I don't want white smoke, but just light gray. Okay, so like I said, it looks like we have a lot of density, which we don't want. So I'm going to change the density to 1, play a few frames. Okay, also it looks like I'm emitting way too much from everywhere, so why don't I just remove some of those source points? So I can go here, visualize my source point, and maybe I get rid of 30% of it, but in random shapes, not just any area. So let's put a warp swap, point warp. I'm gonna create a turbulent noise. Do I have ID? I can use my, I don't have ID here. If I had the ID, did I delete it somewhere? IDP, what is IDP? IDP, that shouldn't be changing, right? So we can use IDP, I guess. No, I don't have rest position. Oh, we could use a rest position for this, so I think we should. Rest position should create us a rest position, and that should give us the bird position, and we can use that one. Oh, that's breaking actually. Rest position breaks our sim. Oh, it's because it's updating here. Okay, maybe we'll just do it here. That's fine. Something small. Okay, so some big gaps, some small gaps, a little bit of roughness, and a little wrangle here. If at color is less than 0.5, remove point. Parentheses here. Okay, that's too much. Maybe less than 3. Some more, maybe 2. Okay, and I can keep that as it is. And then if I go into my sim now, should have more gaps. So if you want to, because we are bringing, actually we don't have our collision geometry here, but we are seeing our geometry. There's a node called render parameters volatile, so I can plug this green bar to this guy, and then if I put the display, it's gonna disappear. I can do the same thing for my source points, so I don't see them, but maybe I want to see my geometry that is affecting my sim. Okay, I think the problem is we are emitting way too long and not advecting enough. So it could be like explosion and then stop emitting. We're just emitting way too long. I think that's because we have too many points leaving all the time. So maybe let's just animate that with a delete range, I suppose. Delete range. No, range. What was it? It was on delete. Yes, these used to be all one and now they're all mixed. There's many of them. Points, delete by range. I guess I can say 100. So if I should be removing, no, delete non-selected. Why 51? I'm just trying to animate it like delete over time. Come on, how many points is there do we have? We have 49,000, that's 50,000. So if I animate that, it should, if I go 50,000, it should remove everything. Okay, so which means I can start with 0, put a key, and then go to 50,000 to remove every source point. Okay, so then if I dive inside, at least I know that it's not going to emit every frame. Okay, now what we need is a bit more, I think, advection. Let's try this guy. Let's put 10. I'm gonna put 50 again. Here we get some more advection. That's cool. Here is some push. Here's some pull. That's creating the mushrooms, but that's fine. We're gonna fix that. Okay, that's too much, obviously. Let's go 25 again. Just the distance is too short. We can probably push the turbulence. We don't have turbulence here. Interesting. I didn't have it before, but now I'm gonna have it. Turbulence, I'm gonna put it to 6. And I'm gonna put the swirl size to 5 meters. Grain to maybe 75. Okay, let's press play. This should help us with those mushrooms. Way too many mushrooms. It's too ugly. Maybe we can again key the advection. Here I'm gonna put the 2. Okay, and I think I'm going to change my disturbance to like something like 10. It's temperature, right? Yes. Okay, let's press play. I think we can increase the size of our advection, the disturbance noise. disturbance, maybe let's change the block size, or we can change the turbulence to something smaller. Instead of 5 meters, let's try 1 meter. Okay, so that can go quite a long time until we find out some proper values. So I'm going to pause the video. I'm going to find some proper values so we can continue. Okay, so I think these are the values that I can leave with at the moment, at least. Well, this is not a PYRO tutorial, but this should kind of give a good head start. So I realized that when I was, because I hook up my resize to my source, but then I was eliminating my source over time here to have less temperature. So I changed that now to density, because I want the pieces to emit density all the time. So that's kind of what's giving me here. So I make sure that the density is the new SOAP tracking object. I also copy pasted the temperature, but then I am saying don't emit temperature, just emit density, so we keep getting some kind of smoke trail towards the end, but not just fire. So if I press play, that's kind of what I'm getting. There's a few settings here as well. The field force, I changed the, it was getting too much advection, so now it's 6 instead of 10. But again, if your simulation looks different, you may want to play with these. This all depends on the speed, etc. Which tells me here, I think we can play a bit more with the density, I guess. This is just for visualization, obviously, but I think that should kind of give something interesting. Let me try to play, add a little bit hotspots. So if I press play again, and then at frame 300 our source is ending, so that's why it's gonna come to a stop. So ideally we want to simulate something longer, but it kind of resembles something being just really badly crashed and burned. And I think we have too much noise though, so you may want to play with the amount of like shredding here. So if you turn off the shredding, and I guess the turbulence for now, and then debug each one of these features by themselves to make sure that they are generating what we need. To see if we have too much noise or not. So I think this level of noise is fine. So I guess we can then change the turbulence swirl size to like 10 meters. So it kind of creates a bit more crazy turbulence in certain areas to break up the shape even more. Anyway, so on and so forth. These are the values that I suggest you play until you get something that is cool. Obviously, after we are happy with what we are doing, we did our volume compression technique, which I'm going to use here as well. Volume resample, volume blur, which we did that before. I'm just copying it from the other scene. Then we do import fields to bring in our PYRO here. Where is PYRO? Here. So I don't need any of these. I can leave it temperature only, that's fine. And actually let's keep the heat as well. We're compressing a lot of information anyway, so we can have some a bit more controlled shading. So let's dive inside here. I want my, oops, sorry, lock it in, and no, not here, here, lock it in, and drag and drop your PYRO object here. And now we should be fetching the proper information out. Yes, obviously I think we can use a bit more higher resolution, but for now I'm happy with what I have. So again, if you want to check 4 megabytes, 1 megabyte, that's good. And I'm going to cache this out. So file cache. Let's get the name from here, and we can say PYRO sim here, PYRO sim, and the same frame range is important, is 282 to, let's say, 325. Okay, some more. Actually, well, we're gonna cut the camera at 300 because we have only 18 frames of sim, so that's good enough for us. And we'll call this PYRO sim, and I'm going to save my scene and save to disk. My low-res sim is being cached out. So I guess now in the next tutorial, in the next video, we will prepare our rendered nodes, and we're probably gonna render a single frame of a shot that has everything to conclude this tutorial. Okay, thank you for watching.